Hi everyone, welcome back to Gallant IAS. Today we're going to learn everything you need to know about rock systems, its structure, its type, how it is formed, and everything and all other facts related to UPSC exam, both prelims and mains. So let's get started. Now before we start, there is one important fact I need to remind you about. It's about your maps. Every year they ask a question from, usually every year they ask a question from your maps. And it is quite often that it is harmlessly easy, given that you already have did your revision with your maps and you're familiar with your maps. To do that, you need to start early. You need to start now. Whenever we are discussing a topic in your regular syllabus, do yourself a favor, go back to your map, refer it, understand it. Whenever we mention about an ocean or a sea or a new country or a new landform in a country or in a distant land, go to your atlas, check it out, understand its location, understand the place it shares in the world, understand its continent, its context, neighbors, understand everything that you need to know. Don't mug up, just get in a habit of looking through the maps and finding its location and its neighbors. It will be easier if you start now. Most of us, what we do is we push it till the end. We keep maps till we know it is important. We know it is easy if you know it, but we keep pushing it till the end of our preparation. And at the end, the cost of spending time reading through the maps becomes more than the return on that investment. So what we do is usually we skip. The first things that we skip in geography usually comes to be maps. So make it easy for you. Start now. Start today. When we are discussing anything, go back to your map. Go back to the map of India. Look where Deccan Trap is. Look where River Ganga flows through. Look at the states. All that. Okay. And for that, you can rely on any standard atlas. Oxford is the most preferred one. It's not necessary that you need to buy that, but any standard atlas would do. And moreover, you can use technology. You have access to Google Maps, which is easy, free, and accessible anywhere. So use that. Start with your maps today. So let's start with today's class, which is types and character of rocks. Now, we call the place that we stay, the area, this top portion as lithosphere. Lithos literally means rocks, sphere of the rock. Lithosphere includes two things: your crust, the entire region of the uppermost part. If you remember correctly, you have a core, then you have your outer core, which is liquid core, mantle, then your crust. So lithosphere consists of both crust and upper part of mantle. Crust plus upper portion of mantle makes your lithosphere. So when we talk about Earth, we have to talk about the rocks that compose this lithosphere. Now, when we rank elements based on the abundance with which we find them on the Earth, we can divide them into this. If you consider the whole of the Earth, the entire materials in the Earth, we can say that iron is the most abundant material on the Earth, then followed by oxygen, silicon, and magnesium. This list is important. Take note, pause if you want, take this list down. It is important. They could ask you this question. Now first we were talking about the whole of the Earth. But what if we take only the crust, only the upper part, not the lithosphere, because lithosphere has both crust and the upper mantle. But what if we consider only the crust, only the uppermost part of the Earth? Then the distribution changes. Oxygen is the most abundant element there. Then comes silicon, aluminum, and iron. Remember this, it's important. So, these are the elements found on the Earth, and these elements these and many other elements combine in different forms to form what we call rocks. And they are most often found in compounds. They are not found alone. Iron is not found alone. whatever you need, aluminum, iron, or copper, you have to mine them, you have to refine them to extract the amount in which they are required. It is not found alone. So it composed of all the elements mixed in different fashion. Now that is how a rock is formed. Now let's classify the rocks to better understand it. Rocks can be divided into three, which is igneous rock, sedimentary rock, and metamorphic rock. We'll start with igneous rock, and there is a reason why we are starting with igneous rock. Igneous rock is also called as the parent rock. Can you imagine why that is? Because igneous rock is the rock from which all other rocks are made. It is from which we get sedimentary rock. It is from which we get metamorphic rock. So that is why rightly we call igneous rock as the parent rock. And moreover, if you look at its origin, igneous rock is made up of magma cooled and solidified. When you cool and solidify magma, you get igneous rock. You know, the magma comes from the Earth's mantle. The magma, this is the crust, this is the mantle. So the magma that we find on the surface is coming from mantle. There is a small region called asthenosphere just below the crust, that is from the magma comes out onto the crust. And when they come out, when they cool down and solidify, we get what? We get igneous rock. So we can further divide igneous rocks into two. Now before we get into that, just remember there are two important facts. I forgot about that. We'll deal with them now. There are two no-nos when it comes to igneous rock. One is you will not find any fossils in them. Two, the second one is you will not find layers in them. It is not a layered structure. So two no's when it comes to igneous rock, remember them: no fossils and no layering. Can you imagine why there is no fossils in igneous rock? Simply the fact that during its formation, it is made up of magma. During its formation, the magma is really, really hot, and any plant or animal remains happen to be unfortunate to fall into them will be instantly burned up, leaving us with no evidence of the bygone days. So that is why we don't have any fossil records in magma, in igneous rock, and we don't find layering in igneous rock because they are all formed in the relatively the same time. Okay, now igneous rock can be further divided into two: intrusive and extrusive rock. As the name suggests, intrusive rocks are rocks which form inside the crust, which are cooled down and solidified inside the crust. Extrusive rocks forms on the surface of our earth. It forms on the surface of the crust. Now, magma is coming up from the mantle. I told you it comes from the asthenosphere. It is moving up with force, and it finds a crack and it pours down as lava onto the surface. That is your igneous rock. That is your igneous extrusive rock. Now, if the magma is coming up, this is your crust. They have a large area to cross before it reaches the surface. What if they can't find an opening to come out? If they collect here, pool in the crust itself below the surface and solidify, you get intrusive igneous rock. Okay, now the character of these two differ because the process of cooling is much faster in the extrusive igneous rock than the intrusive igneous rock. Extrusive igneous rock cools down much readily, much faster as compared to intrusive igneous rock. So extrusive igneous rock is more fine-grained than intrusive igneous rock. Now, intrusive rocks can be further divided into plutonic and hypabyssal rock. Plutonic and hypabyssal rock. So we are talking about the igneous rock which are forming, cooling and solidifying within the Earth's crust, and then we can further divide them into plutonic and hypabyssal. The difference in them is simply the depth at which they cool down. They are both underground, but the depth, if it is really, really deep in the Earth's crust, we call it plutonic rock. And if it is just below the surface, we classify them as hypabyssal igneous rock. So that is the entire igneous rocks division.